Hello, hello, hello. Thank you for joining me today. I am super excited about this topic, and I'm super excited about the crowd that we have to visit. Um, it, every time you look at financial reports for how much your development team takes up on your budget and how expensive just any software engineering team is, you're confronted with this question. Okay, how much are we getting back? What's the return on investment? Um, and they're expensive, but you need the software team, but your gut is telling you, okay, we should be able to deliver faster with fewer production disruptions and a lower defect rate. Your team is working hard, often working late on weekends. It's not the problem is not effort. The problem is not um, how much effort is going into it, how hard people are working. You've got dedicated people and they're working hard. That is good. But we need to figure out how to deliver what's asked of us at a faster rate. We can't just work more. That doesn't work. There's plenty of studies behind. We're not going to work more hours. We just work in a different way so that we can actually deliver faster. And so this webinar focuses on the changes that we can make as software leaders to empower the team with just a different way to aim that effort so that overall our software delivery is twice as much for the same unit of time. And in fact, these changes are going to enable us to get those results, even if we might even say remove some developers from the team after we've gotten this traction. And so you're going to come away today with a clear understanding of the process changes and additional practices to introduce, as well as how to think about this and how to measure your progress. So let's get into it. Logistically, there's a Q&A window if you want to ask some questions throughout the webinar, and I'm pretty good about working in the answers to those as we go. A little bit about ClearMeasure. We are a software architecture and engineering firm, and we partner with software leaders like yourselves to transform the way that you do software delivery. We have a proven expertise, and that optimizes processes, it unravels complexity, and accelerates time to market so you can rapidly deliver the innovation that you're seeking to. And so we'd love to help you out if that fits. A little bit about me. My hobby is amateur off-road dirt bike racing. I am thoroughly average in that, mid-pack, and we live just kind of off to the west of Austin, Texas, where the country just starts. And my middle son is changing a tire there because he's done some of that racing as well. So that's a little bit about me. A free offer for any of the developers on your team. My latest book, .NET DevOps for Azure. If you'd like a complimentary ebook version of that for any of the developers on your team, then they can just send me an email. I'd be happy to get that to them. All right. So at ClearMeasure, everything that we talk about kind of sits under a way of thinking. We've colloquially called it the ClearMeasure way. And this way of thinking is for effective software teams, because what we believe is when equipped and trained properly, every team can be successful. And so this simplifies and synthesizes known practices in a manner that any software team can implement. So we'll be talking a little bit about that. Now, to get into our topic, I want to bring up something, kind of a well-known figure, Edwards Deming, W. Edwards Deming. Now, he's published so many books and articles. He passed away in 1993, but he was a leader in the quality revolution after World War II. And he's published hundreds of papers and articles and books. And one of his ideas is the Deming cycle, which is used in quality control. And it really has an impact on the way that you lead your software engineering teams. So the Deming cycle, or the Deming chain reaction, is kind of how it goes. It starts with improving quality. We're going to dive into that. And when we improve quality, then we have all kinds of things that go well. We have less rework. We have fewer mistakes, fewer delays and snags. We have better use of our equipment and our resources. And when that happens, when those costs decrease, and we spend less on rework and mistakes and things like that, well, productivity improves. And then when productivity improves, as a business, we can capture the market share because we're offering better quality to our customers. We're probably able to offer them a lower price. And when we do that, well, guess what? We stay in business. Our business gets healthier. Our business grows. And then when that happens, we are providing more jobs. Okay. And then we do the cycle again with more people, with more innovation, with more customers. We figure out how to improve quality some more, which goes through the cycle again. So you can, if you care to, you can read the book Out of the Crisis. And you can dive into that. But I want to relay it to some survey information of our industry regarding where our time is going as people in the software development team. So you can refer back to this article. I've linked it at the bottom from computerworld.com. But this industry survey found that most individual contributor software engineers spend nearly a third of their week in meetings. Okay. And what that means is just looking at the pie chart, a little over half the time is focused. Actually, nobody's bugging you. I can just do focused work. Okay. A little over half the time, 20 hours out of the measured average, 36 when it comes to, taking vacations off of whatnot. Okay. And 11 hours in meetings and 6 hours in fragmented time. Now we all have fragmented time. That's checking email in between things. We're not quite focused. We are kind of working, but we're kind of doing various little things. We're not in focused working time, working on software development. All right. So this concept we're going to have to tackle because right then and there, of the capacity that we have in our development teams, a little over half is actually focused on the features that we're asking the team to do. So just as we're doing our budgets for how many developers that we have and how much time we have, just doing capacity budgeting, already that's getting nearly cut in half because of this dynamic. So that's something that we'll keep in mind we have to tackle as we figure out, what is our capacity? Also, when it comes to software, it's good for us to keep in mind what baseline productivity levels are for programming tasks. So we have some industry research to leverage. There's no one definitive answer, but Fred Brooks, he published that decades ago, lines of code per day baseline was around 10 lines of code per day. Okay, in the 1960s. In the OS 360 operating system project. Great. Capers-Jones has also published research from over 19,000 projects and correlated together. I love his research. And the smaller projects, less than 1,000 function points, average lines of code per day, 38 lines of code per day per developer. For larger projects, which are greater than 10,000 function points, it goes down to around 16 lines of code per day. And Steve McConnell has also published some research, and it's not that far off. It just has a bigger range. In the smaller, in the very small projects, which is 10,000 lines of code, and roughly, by the way, one function point in Capers-Jones's research, one function point typically can be implemented in around 52 lines of a high-level language like C#. And so 10,000 lines of code, these are really small projects. And the lines of code per day is from 20 to 125. But larger, very, very large code bases, 10 million, or so, it goes down to 1.5 lines of code per day to 25. But if you're just going to stick your finger in the air and try to just pick a reasonable average just for some economic budgeting, 25 is a safe number. And we use that all the time. And now I do have projects where after the project, I go back and I look and say, okay, what was the average? And projects that use practices that we recommend routinely get up to 100 to 125 lines of code per day, even when they creep up to 2, 3, and 400,000 lines of code. So, but these are industry averages. You don't want to be average, okay? But unless you've done specific things to be average, then you need to do that. Okay. Now, I want to go back to this quote. If you can't describe your plan, you don't know what you're doing. All right. So we want to make our software team productive. We have a project in front of them. We need them to be better than average. We have good people and our people work hard. So it's not about asking our people to work harder. They're already working hard, but we need a plan for success for the project. So that's what this is about. Okay. I want to stress that. Okay. So with the baseline, let's allocate some development team time. So we put in the pie chart, we put in the pie chart some developer time split between debugging and development. And when I'm gonna go to this slide. Let me talk about defects and the costs of defects. Okay. We have cycles as represented by this concentric circles and these onions. Developers write some code and then they send it up, they share it with the team. And then the team puts together a build of the software, shares it with whoever does product management at the company. And then product management, whoever does that at the company, shares it with the customers, gives it to them. And they're going to get feedback. Each of these has an independent life cycle. And when a defect is caught, when a developer is coding in the center, well, that's a really short cycle time. But every time it gets promoted to the team and doesn't get caught, every time it gets promoted to product management, doesn't get caught, and then every time it doesn't get caught and goes up to customer, that's an order of magnitude cost. Okay. And there's plenty of studies out there that talk about the exorbitant cost of escaped defects. And the IBM System Sciences Institute, has research that shows that the cost of fixing a defect is 100 times what it is when it's out in production, when the software system is just used, when it's in the maintenance phase, than when you're designing it or you're implementing it or you're testing it. Okay. So we go back to lines of code per day, and that's all great. But if we are generating defects, well, we're not just writing features. We're actually sending defects out and then having to spend a lot of time to fix the defects. And there's other research that shows that half of all developer time goes to finding and fixing defects. Okay. So this graph takes into account the focused time, which was just a little bit over 50%. And if half of the time a developer is spending in focused development is spent on fixing defects, well, now look what the graph shows. Debugging 27% of the time, development 27% of the time. Now we're in meetings still 30% of the time. And then our fragmented time is 16% of all time. Okay, that's our breakdown. So when we think of features that we want to ask our development team to design and develop and get to our customers, already without a specific plan to the contrary, they're only spending 27% of their available time working on the features that we've asked them to. Okay. We are going to change that. And I want to show you how to change that. Okay. This is a bit dense, but Capers-Jones has an immense amount of research on defect removal, causes of defects, and techniques to find them and fix them. So this particular table number 2, it happens to be from an article called Software Defect Removal Efficiency, and you can find that very easily online. But there's a list of defect removal techniques that are before software testing in the software development lifecycle, and then techniques that are used during testing. And you can see the minimum and maximum effectiveness, what we call defect removal efficiency, and formal design inspections have an average of, okay, we're going to find 87% of problems, of defects in the actual design. Formal code inspections, we're going to find 85% of the defects in the code. Static analysis, 85%. Pair programming actually averages only 55% on top of being very costly, which is kind of why it hasn't probably really didn't catch on for 20 years. And then there's all the different techniques in testing. There's automated unit testing. There's independent testing at the very bottom. Just have a developer kind of independently test the code, or have just an independent party. But what Capers-Jones found is that if you combine a few highly effective techniques, then you actually get a combined benefit. So, for example, if you take formal inspections, like the formal design code and requirements inspections, each of which average 87 and 85 and 78, then you're already getting in the 90s. And then you add on some of the testing techniques, and then you add on static analysis. In his research, that combination is the most effective and reliably gets teams around 97% and above defect removal efficiency. Okay, so when thinking about the industry's track record of developers spending half of their time finding and fixing defects, as a strategy, you can adopt some of these formal inspections, static analysis, and some of these testing types that are at the top of the list, and get your team up to 97% defect removal. So that's just a strategy change and putting in place some of these techniques. Okay, not asking developers to work longer or work harder. Let's just change a little bit about the way we work, and let's capture some of that time. All right, so we're going to do that. And there's 2 ways that we can lower the time spent on defects. We can prevent more defects so that they don't happen in the first place, or by prevent, we're going to basically find them super early. And then we're going to find and fix defects quicker, the smaller set that actually does escape out to our customer or even out to product management. So for preventing more defects, we're going to put in place static analysis, testing, and formal inspections. We have plenty of other content diving deep into each of those. I invite you to go to our webinar archive. And for finding and fixing defects quicker, we're going to make the work more visible and have a process that inspections can layer on top of very easily. We're going to implement automated DevOps practices, so we have a very, very short cycle time so that any defect that does slip out can be fixed much more quickly. And then we're going to add real-time monitoring and self-diagnostics so that our system, while it's running in production, is helping us find issues and alert us in real time so that we find and fix those defects a lot more quicker as well. So let's dive into making work visible and where to layer on some of these formal inspections. So if anybody has read about the DevOps movement, which is now 13 years old, the first way of DevOps is systems thinking or making work visible. Okay. And it starts with the tracking system by which you actually enter all your work. What kind of ticket system do you use, whether Azure Boards, whether Jira, any kind of project management system, and all of them have kind of a board visualization where you move cards from the left to the right. And what's important is for each of these columns to be a stage in your software development lifecycle. And the Agile movement has taught us that instead of large batches of software features moving across this process together, we should drive down to a batch size of one and iterate on that so that we have one feature or one change where we can think about the concept, think about the requirements and the business objective, then move it along to user experience design and think about how is a person going to use this change? What are they going to experience? What's it going to look like? And then move it along to technical design and make architectural determinations or design patterns or choose some of the libraries that you might use to implement it. And then move it along to test design, which kind of gives us our definition of done for that particular feature or change. We break it down into its piece parts and we determine how many exception paths we want to support, what the real scope of it is. And now with those 4 decisions made, we can send it on to the people who are doing the programming. And of course, those people, participate upstream as well. But now it's time to actually write the code. And after the code is written, we functional validation at the team level to make sure that, okay, it does work. Then we send it on to product management so that they can validate the user experience, so that they can make sure that it does work the way it was intended to work. And then we move it along to release validation, get it ready to send off to the customers. And then, of course, it's released to the customers and it's done. And so requirements inspections go very well between conceptual definition and user experience design. Whereas whoever is assigned to determine and writing down what we expect the user experience to be, how it should look, how it should behave, if we have a checklist for completeness of requirements for that particular feature, not a whole bunch, but for that particular feature, well, now we formalize the inspection. And in test design, if we have a checklist for what it means to have a complete design from a UX and a technical perspective, well, now we've added some formality to that inspection. And then in functional validation, if we have a checklist by which to look at the code that was used to make that feature happen, well, now we've added some formality to the code inspection, and we're getting the benefits that Capers-Jones has determined in the research, the benefit of formal inspections. So I want to talk about the developer flow in your teams and where to add that formal inspection when it comes to the programming. So when a change is made, that's made on the engineer workstation, and the engineer, the developer does the private build, does a commit to the Git repository. On the build server, we do our integration build. That's the perfect place for the static analysis, by the way, for the automated testing that's built in. And then in a test automation environment, we do our first deployment, and that's where our full system acceptance test suite can run in a fully deployed instance of the new build of the software. And then back on the engineer's workstation, with high confidence that what was just done is good, he can create a pull request. And when that pull request is approved, if we approve it by way of a checklist, well, now we have a formal code inspection. So the pull request process, even if you have just a peer team member look through what was done, but does so based on a checklist that you create as your team, well, then that's the perfect way to implement a formal code inspection. And then you get the defect removal benefit of having formality in that process. Just creating a checklist gives you the formality for that to yield the returns. For automating DevOps, it's not rocket science. This diagram right here is the standard flow of an automated DevOps environment. Now, there's a lot of technical jargon on here, and I know you probably can't read some of the words, which, by the way, if you want a full-size, high-resolution PDF copy of this for your development teams, just send me an email. I'll be happy to send it over. But there is a standard structure for the flow of an automated DevOps environment. If you don't already have it in place, then your teams have a much slower than necessary cycle time when making a change, sharing it with the team, getting it to an environment, verifying that it still deploys, getting it to a manual test environment so that someone in product management can look at it, and especially getting it to production. So consider this some of the basics of foundational capabilities that your software team needs when it comes to DevOps. And you don't have to go all the way, but just put this basic structure in place to decrease the cycle time, make it faster for them to make a change and get it all the way through, regardless if the change is super small or larger. Now, there's a book called Accelerate from the Dora Foundation, and of course they've been acquired by Google since. But in that book, they referenced the latest, at the time of publishing, the latest State of DevOps report. And one of the findings was that elite performers, that is, elite software teams, have a 7 times lower change failure rate and over 2,000 times faster time to recovery from incidents. So 7 times lower failure rate of putting something into production. And then if something happens in production, if something goes awry, recovering from that is not just twice as fast, 2,000 times faster. Okay, that's insane. So just get the basics in place. And even if you don't get to the 2,000 times faster this year, wouldn't it be great to be twice as fast, 10 times as fast, 100 times as fast? So start plugging away. And one of those ways is to get the basics of DevOps automation in place. The latest survey from earlier this year, 2023, the State of Continuous Delivery from the /data survey, was those who use continuous integration and deployment tools are significantly less likely to be low performers. Okay, so we can see just in lead time for code change, the graph on the left, the teams that are using CI/CD tools have, for the ones that have less than 1 day lead time for a code change, there's more of them use CI/CD tools. Okay, so the green bar is better on all of the short lead times. And then the more than a month lead time, not using those, there's more people who don't use them that have those longer, more than a month lead times. Okay. Let's touch on monitoring, self-diagnostics. Every software system that your teams run in production needs to have an operations dashboard, a command center. It needs to have a NASA-like dashboard of what it's doing. And this is just one example of a chart that you would want to look for. You'd want to know what your software is doing. This happens to be from an online auction system, and this happens to have more usage on weekends. And so you can see some of the seasonality where a few of the events were selected, where a buyer was registered, or we're going to submit a new bid. There's more of those events happening on the weekends than in the middle of the week. So you can see that going. But at the same time, from July to August, you can see an increase in overall usage on the weekend auction events. And of course, the green check marks at the top are times when the system was deployed to production. And so there's all kinds of metrics that you need to be pulling and looking for when your system is running in production, so that you can correlate them together. And if one of those goes sideways out of threshold, you need to have automated real-time alerts so that you find issues a lot faster. So put in place your dashboard for real-time monitoring and self-diagnostics. All right, so let's come back to where your developers are putting their time. Remember, without a specific plan to the contrary, on average, the focus time is only around 54% of all time, okay? Around 54%. And half of that is spent on debugging, is spent on defects, right? That's that. So let's analyze this economically, all right? So to review, just over half the time, on average, developer spend is focused work time, and half that's debugging, working on problems rather than new features. By using the defect removal techniques that are proven through research, we can remove around 97% of defects before they hit our users. But let's be conservative and say we find and remove 90% before users are impacted. Did you see that gray piece of the pie grow? Just with that increase in quality, we have doubled the time our developers are able to allocate to focus development. Again, I haven't even touched on how productive the focus time is. Just, we have more available capacity now that is allocated to focus time. But we don't have to stop here. With a fully visible workflow and requirements inspections and design inspections baked into the workflow as work moves across the Kanban board, we prevent defects even before coding, and we offer clarity to the people writing the code. Some of the meetings are, scheduled meetings, and that 30% of meeting time is never going to go away completely, because we all need to be on the same page. When all work is made visible, though, the process gets everyone on the same page and not just the meetings. And then our people can focus on more work and less coordination. Overall, clarity is kind. It is kind to be clear. And so let's be kind to our people. Now, with the full objective, design, the flow, the architecture, and the scope, when all of that for every feature is very clear, a developer doesn't have to stop work to have an ad hoc meeting in order to obtain answers to questions. Remember the stages. If a developer starts on a feature and has to stop, time is lost. Perhaps it's only 30 minutes to speak to somebody about how many scenarios a feature should support, how many exception paths, error messages, if something doesn't go as expected, things like that. If there's clarity needed on the architecture or the design pattern or which library to use, the things that should be determined during the technical design phase for that feature, well, then it's probably an hour or a couple of hours that are lost, and then another ad hoc meeting. Or if there's a question about how something should look or how something that should behave, the UX in a particular scenario, that's another ad hoc meeting again. Probably with somebody in the product team around user experience. That's probably half a day that's lost. And finally, if there's confusion around how the business objective is going to be met, well, that cycle time is even longer, probably days, not hours. So making all the work visible and preventing features from having to go backwards severely limits ad hoc meetings. And so with a little bit of focus in this area, we can reclaim some of that meeting time and then grow that gray slice of the pie even more to get up to 2/3. So now look at that focused development slice of the pie. That's huge. And again, regardless of the current productivity of how fast the developers go per unit of time, just making capacity reallocations, we've more than doubled the output of our team. And we still have the question of how to make the developers more effective through other practices that they probably should be using during their focused development time. But that's for another webinar. There's more gains to be had. Obviously, that's out of scope for here. So, but the overall, there is a chasm, and the chasm between average software teams and great software teams is currently immense. But it doesn't have to take an immense amount of effort to cross that chasm. The knowledge and practices and tools are pretty well known, and with your leadership, it will happen with your team. Now, we love helping teams along this journey, whether you're in an in-progress project or a project that's being planned, put it on firm footing. So we have a free assessment that you can use to gauge how your team stacks up, and I invite you to use it as a free resource. I think that we have put in the free resources in the chat as well, the poster, and I did answer a few questions as I was going along, but if there's any questions that come in, then I'll answer those or stay a little bit if anyone has a follow-up question. But I wanted to share how allocation of capacity severely impacts your ability to move fast and how you can double the output of your development team just by changing a few things, not adding developers, not having the developers work harder or work more time, but with a little bit different strategy. And of course, from the benefit of your good leadership. So I'll stick around if there's any more questions, but thank you so much for your time. I know it's valuable, and look for the next in our webinar series. Thank you so much.